Awesome. Now that we've had some practice with just doing lines by themselves, now let's start looking at our system of equation. So these systems here that we're looking at, that's top system is going to be a line. And again, we're going to need to get that y by itself, and then we'll have our line. But what about this bottom one? That's not just a line. What's that? Ooh, it's a parabola. Awesome. So we're going to be looking at this parabola, and we're going to do this basically bringing it back, right? It's been a while since we've graphed a parabola, so we're going to this will be a nice review on how to graph a parabola. Cool. So let's do it right now. The first thing we're going to do here is our line. So I have x is greater than a 6 minus 2y. Now, I don't really want to mess with this negative in front of the 2y, so I'm going to go ahead and add a 2y to both sides. Now I have 2y plus x is greater than 6. And now I'm going to subtract that x. Oops. So I have 2y is now greater than a negative x plus 6. Divide everything by a 2. And y is now greater than a negative 1/2 x plus 3. So I'm going to use that purple here. I know that I'm going to, with my symbol, be shading above my line, and it's going to be a dashed line. Good. And then my slope here is going to be a negative 1/2, and my y-intercept is going to be the 0.03. So let's do that. I'm up here at a positive 0.3. My slope is a down 1 over 2. Especially when you have a system of equation, you definitely want to make sure that you are filling up your coordinate grid. And then I know that this is dashed. And I'm shading above. With a system, a lot of times I just like to put lines in there because then my solution to a systems of equations is when they intersect. Just like if you have a solution to the two lines, it's where the two lines intersect. This is where the shading intersects. So now I'm going to take a look at my other value here where I have my x squared is less than 2y. If I divide everything by a 2, I have a 1/2 x squared is now less than y. Because I like to have that on the left side, I'm going to actually write this as y is greater than this 1/2 x squared. Now, with this parabola, I know it's the same scenario applies. This is going to be shading above, and I know it's going to be a dashed line that we're looking at. So it's a parabola. So how we're going to do this is we're going to make our x, y, new y chart, right? And I'm going to kind of write over the top of my grid because I know I'm going up with this, so we're good. So always for the x, the pattern is going to be plus or minus 1, plus or minus 2. My y, when I square positive or negative 1, you get a 1. If you square positive or negative 2, you get a 4. Then my a value for this is going to be a 1/2. So then you multiply the y times the a. So 1 times 1/2 is going to be a 1/2. And then 4 times 1/2 is going to be a 2. I'm going to cross out these two middle terms just so I know how I move. Our vertex for this, because remember, the vertex is the star of the show, so you always have to start with your vertex. Your vertex for this problem is going to end up being a 0, 0, because I have a 0 next to the x, because it's like a 0, x minus 0 squared, and then there's nothing in the back, so that's also a 0. So I know my vertex here is 0, 0. Then I'm going to go to the right 1 because the x is over 1, and then up 1/2. I'm going to go back 1 and up 1/2. Then I'm going to go over 2 and up 2, back 2 and up 2. And so now I'm going to make a dashed parabola. Now the question is, am I going to shade above or below? And what does actually above or below mean with a parabola? Think about this in terms of the y-axis. You are looking at your y values that are greater than 1/2 x. So if I'm looking on my y-axis, where are the y values greater? Up above, right? So if I'm looking at this up above here within this, I'm going to be shading on this inside part. So the question here that I'm looking at is, where do these overlap? That's the real question. That's what I want to know. So if I'm going to determine if these values overlap, then I want to have, I'm going to do a yellow here. So where they overlap is in between all of this. That's where the red and the blue intersect, and that is the actual solution to this system of equation. Does that make sense? So you can have two lines that cross, you can have a parabola in a line, you can have several different things that you're looking at that intersect. And that's the goal, and that's what we want to say is, okay, so where do these two intersect? Where do they both shaded? And that is our actual solution. Cool, let's do another one. Okay, last but not least, check this out. So we've got a line up here at the top. This is example smiley face, because I'm pulling this one out of the exercises just so that you can see another scenario here and review how to graph a circle will be nice too. So this top one here at y is less than or equal to x. So that's a line, right? Because nothing is squared, nothing is messed around with here. So my slope for this line is going to be a 1. My y-intercept here is going to be 0, 0, because there's no b value, so it's a 0. If I'm looking at my symbol, I know this is going to be solid because it's an or equal to, and y is less than x, so I know I'm going to be shading below. So let's do it right now. I'm at 0, 0. My slope is 1, so that means I'm going to go up 1 and over 1. Fill all those in. That's a nice slope. Too bad it's not a dashed line, right? Because that would basically already be done just with all these dots. But this is a solid line, so we'll connect these dots. Put our arrows on the end. Now, for this, if I have an x squared plus y squared is less than 9. If you have both an x squared and a y squared, what type of graph is that? Do you remember? It's been a while, right? It's a circle. What? So now we get the opportunity here to graph this circle. Awesome. So our circle is x squared plus y squared, which means this is in center radius form. So I want to come up with my center for the circle. Remember, the center is next to the x and the y. And if there's nothing there, then what would my center be? 0, 0. Awesome. What about the radius? Yes, because it's a squared, right? This is my r squared. So my radius here is actually a 3. Cool. Now, here's the next question. I have this circle. Now, think about what this actually means. Here I have my circle, which is less than my radius. So do you think it's a circle? So am I going to be shading on the inside of my circle or the outside of my circle? If the values that make it true are less than the radius. To the inside, yeah, because the values that are going to make this statement true have to be less than that radius. And I know this is going to be a dashed line because of my symbol. So I'm starting here at my center, which is 0. And then I'm going to go out 3, because that's my radius, up 3, to the left 3, and down 3. And then we connect those dots. And just do the best that you can. And keeping in mind, this is a dashed line. So we're going to make a dashed line that goes all the way around. There it is. And we talked about this shading to the inside. You know what we forgot to do here is we forgot to shade with that line. I'm sure you were all saying that to the video and I wasn't responding. So for my line, I want to shade below. So I never shaded for that one. Let's do it right now. Then let's come back here and shade for our circle, which we said was going to be on the inside of my circle. Now, where do these shades overlap? So if I'm looking at this and I want to see where they overlap, it's this half of the circle, right? Cool. So that is the only place where this system of equation has overlapping solutions, so I know that's my actual system answer. Great. Now it's your turn. Go practice some of these and rock the socks off of it.